Oh, wait a minute for people to. This is the big beverage break, right? Like, so there's actual cookies out there.
What's that?
This is the big beverage break, so there's cookies out there, or is this the? I'm wondering how long we should wait for people to finish eating cookies.
Well, I think we can slowly start, to be honest.
Okay. All right. Hello, all, and welcome to PANRG at IETF 122 in Bangkok. Due to an unfortunate scheduling mishap, which I believe actually some of the other people who are interested in these subjects are probably also over in Happy, which was scheduled against this. As is my co-chair, Jinlin Kova. So she is not able to be there, although she is in person. I am not able to be in Bangkok this time, so I will be cheering remote. And we have Dirk up at the front of the room to help us out. Hi, Dirk. Thank you very much for your service.
No problem.
So this is a meeting of an IRTF research group. The IRTF follows the IETF intellectual property rights. This is the note well slide. We expect that you have seen this slide, have seen the code of conduct, anti-harassment procedures, as well as the BCPs around intellectual property for the IRTF. If you have not and you have questions about this, please review those. But by participating in the IRTF, you are agreeing to follow these processes and policies. So housekeeping for in-person participants, you can scan the QR code to ask questions. We will be running the Meet Echo queue for questions. So please make sure you go through the queue. I'll be managing this remotely. So like if you get in the mic line and you're not in the queue, I will barely even see you. So please do the Meet Echo queue. Keep your audio and video off for those who are remote, unless you are speaking. And you can actually, so I think all of the speakers are in person, so I will be managing those and moving over to the slides clicker for the in-person speakers. So one admittance taker, thanks Nico. Can anyone back up minutes when Nico is speaking?
I can do it.
Okay, cool. Thank you very much, Dirk. So you are here. Oh, wow. It's 5 p.m. there already. Okay. Yes, I haven't. This is my first day doing the IETF remote for Bangkok. I have not yet adjusted to the time zone. It is not 5 p.m. here. So intro agenda, note well. You are here. Oh, we do have 2 remote speakers. Okay, good. So Nicola will start off with Zion deployment and drafts updates. And then we have 2 remote presentations, one on networking awareness acknowledgements for Quick, and one on deadline-aware multipath transport protocol. So unless anyone would like to bash the agenda, we can go ahead and call up Nicola Rustignoli, talk about Zion. All right. Hold on. I think I have to stop sharing media before you can request and I can grant.
Yeah, okay. Now I can request.
Yep. Looks like it's working. Right.
Yeah. You see the request?
I see the request. I have handed you slides control. I don't see them being loaded yet.
All right. Let's give it a minute. And by the way, I would also have liked to go to Happy as well. So yeah, this was
yeah. Yeah, sorry, but I'm the room does look like many people are unhappy, so we apologize for the scheduling mishap.
Let me try again. It got stuck. Okay. Okay, now it works.
Here we go. Perfect.
Okay. That's great. So thanks a lot. I guess if you're here, you probably already heard about Zion, probably many times. So Zion is this secure path-aware architecture, interdomain, focused on routing security. We have production used by various ISPs, especially in Europe. The core specification is in these 3 drafts that you find at the bottom of the slides. So if you want to know more about it, how it works, a good read would be exactly these drafts. And so what I wanted to share today is, first of all, a small deployment update in terms of what are the latest advances. And then you probably remember that we sent the core specification of Scion to the ICE. So this is an independent submission, and the review process happens, let's say, behind the scenes. But I think it might be of interest to this working group to share what kind of feedback we have been getting. So first of all, deployment. You probably remember that Scion is quite successful in the fields of finance. So there is this finance network in Switzerland connecting the banks for interbank clearing. So when you pay from one account to the other. And here the news is that the rollout with banks is complete. So the company running the financial infrastructure is starting to look at the decommissioning of the old Scion network, of the old, non-Scion network, the one that was previously connecting the banks. There is also a new initiative in terms of card payments, so connecting, POS terminals and merchants and acquirers and so on. This with some of the associations that run payments in Switzerland. This network is actually separate from the interbanking network. It is also a bit more open because these machines are a little bit more distributed. And so this got created. There is a SEPN association that will be managing the isolation domain for this use case. There is this education network that also has been growing. So there were a few universities additionally joining. And there is some interest in the utility sector. So there are 2 networks for utility and power that are also being created to connect meters, some of the operators. So we see some interest in Scion, especially in these critical infrastructure ecosystems, where you have many entities that need to somehow reliably communicate. Besides that, there's also the already existing networks in the field of healthcare. There is a blockchain operator that is using Scion to connect its validator nodes together with the internet. So they use the 2 options as alternatives and so on. So this has been progressing, even though we see that the biggest commercial successes are in this ecosystem domain. So this is sometimes moving away from the initial idea to provide somehow a next generation internet, and it moves more into a secure fabric for critical infrastructure ecosystem. That's it regarding deployment updates. What happened to the draft? So the 3 drafts that are currently under ICE review are the 3 core components of Scion. So PKI, control plane doing routing, and data plane. And since last IETF, we got some additional feedback, especially on the control plane. So there was an initiative by some researchers at ETH on formally verifying the control plane specification. And so I'm very glad that the researchers were able to look at the draft and trying to match it with what they had in their own specification. And there they could find some gaps. Sometimes it was really just some small wording, but sometimes there were some things that were not clear. So when it comes, for example, to the routing discovery mechanism in Scion, which is called beaconing, we had to clarify some of the checks that were being done by Scion routers. We also clarified a topic that relates to path policies. So if you're a Scion operator, which of these beacons are you supposed to propagate, which not? We also clarified the trade-offs in the amounts of these messages that get sent into the network versus scalability. We also clarified some of the security properties. So there was some work done also on the security considerations of the draft in terms of what security properties are provided by the control plane. There was actually a missing message format in the gRPC API that is used to communicate, to exchange trust material between autonomous systems. So we had to actually add a couple of gRPC definitions. And then you might remember from the last time, there is a signaling mechanism called SCMP in Scion that is used to report link failures. We actually just moved it from the data plane draft to the control plane draft. That was one of the feedback from the reviewers. On the cryptography side of things, we made some clarifications on the signing ceremony that is used to set up the root certificates, or so-called TRC, for a Scion network, a Scion isolation domain. So we did some wording work. We also clarified some details based on questions that we received. So for example, certificates authorities in the Scion PKI needs to have an AS, and this is required to avoid a circular dependency with routing. So we just made it clearer. We tried to clarify better how these certificates are fetched, especially these TRCs. So we added some clarifications on some of the mechanisms there. So these are small changes. I thought this might be of interest just so that you can follow what is going on the drafts. We're actually looking for more reviews, especially regarding the control plane and the PKI. So if you have a very long flight when you go back, or if you're interested in knowing what this is about and want to read the draft and have some comments, we would be very welcome to receive them. Maybe they could even be part of the ICE review process. So yeah, I would be. We are looking for more reviewers. Closing on this, I wanted to share something else, more from the research side. So we, as Scion Association, also work with the researchers. There's still people at ETH, other universities doing lots of things on Scion. So recently, there has been a push to try to deploy Scion closer to applications, closer to endpoints, because right now in these big production networks, there are these gateways that are workaround. It works, but you get all the benefits in terms of path awareness if you really deploy it close to the application. So they actually made a page with a list of Scion applications that you can check. Another interesting aspect is exploring path awareness in conjunction with quick multipath, and this will be a presentation afterwards, so I won't say anything. Another research development concerns post-quantum. So the Scion PKI that is in the draft is using standard cryptography, so it is not post-quantum safe. And there was some research to upgrade one part of the Scion research network in Singapore to leverage certificates that use crystal silithium, so one of the quantum safe algorithms. And so it was explored how the cryptographic agility in Scion, given that you have very short-lived certificates, helps you to upgrade even parts of the network incrementally to be quantum resilient. But of course, this is more on the research side. The research community is also having some research meetings, and of course, a lot of them discuss topics related to path awareness. So if you're here, maybe you might be also interested in looking at the list. Said that, I think I'm done. So if you have any questions about this, feel free to come to the mic.
The queue is still open. So I did have, like I turned on video briefly to ask a clarifying question, but you mostly answered it. So with respect to people with long flights back who would like to review these documents, should we actually copy the ISE on those reviews?
I think we could, yeah, we could ping maybe the ISE beforehand, so that the ISE can be in the loop.
Yep. Okay. Cool. Yeah, we are looking for more eyes on these. I also owe you a review, I think, but Elliot hasn't asked yet. So cool. Thanks.
You?
The queue remains open. All right. You're around all week if people want to talk to you in the hallway, I guess.
I'm around.
Okay, cool. Thanks much.
Thank you.
Moving on. So I think next we have Tony, correct? Let me take slides back.
We have Gaoxing.
Gaoxing is first. Okay. Are you? Yeah. Okay. I see you remote. Gaoxing, can you ask to share slides? I can. Yeah.
Can you?
Yeah, I'll bring them up. One moment. I can pass control, and you should be able to pick your deck. Yep. Perfect.
Okay, can you hear me?
Yes. I can hear you. I assume the room can hear you as well.
Okay, hi chairs, hi everyone. My name is Gaoxing from China Unicom. I'd like to present and discuss the topic, quick network awareness acknowledgements. It's a scheme that introduces path awareness into the transport layer or application layer. The co-authors include the Meng Yao, Ruan Zheng, and Shi Hang. Okay, as we all know, the importance of the perception of network status by the end side. Regulating by the end side can better meet the application needs of the user side and better adapt to personalized scenarios. And it can adjust the pace and the speed in a timely manner and achieve rapid response. In certain scenarios, such as in the field of massive data supercomputing, it requires long-distance transmission of massive data. Collaborative intelligent scaling between terminals and the networks is required, and the local side knows the available bandwidth and other information of the network, thereby achieving rational utilization of network bandwidth resource, reducing data transmission cost and improving data transmission efficiency. This chapter proposes a quick egg frame format for notifying network status information. Based on the extension of the quick egg mechanism, it supports carrying network status information such as available path bandwidth and path delay. The network status indicators are quickly notified to the endpoint, which is used to achieve path selection, load balancing, rate control, and other operations. Let's review the triggering mechanism of a quick egg. The confirmation mechanism of a quick protocol generally involves the receiver immediately replying to an egg message after receiving a specified number of data packets, waiting for a specified time delay to reply to an egg message, and so on. This draft extends the condition for triggering egg. When the IP header of forward path contains network status information, the egg confirmation is triggered by the receiver after receiving the data packet, and the egg creates the network status information to notify the sender. During the process of sending packet from the sender to the receiver, in-band telemetry information is inserted into each router along the path, including path bottleneck bandwidth, time step information, congestion information, as well as routing ID and port ID, and so on. The specific implementation method can negotiate to change the peer's confirmation behavior by defining new quick frame type. Alternatively, initialization configuration can be performed at the receiving end to enable the receiver to generate an egg when receiving a message which contains network status information. Here involves a question of when to notify. I think it's necessary to support generating eggs based on packet feedback or time cycles. If multiple packets may be received within a cycle, the net state information carried by egg can be based on the last received packet. The definition of network-aware frame format is as follows. Similar to regular egg frames, the difference is that the ECN count is removed, and the net information such as congestion is placed in the network information field. Egg frames contain the following fields. When tab is 0 is to 0, it indicates that the X creates net information. Of course, this value needs to be applied for allocation. The definition of largest acknowledged egg delay, egg rate count, first egg range, and egg range, egg range remains the same as before. A new field has been added here. Network information. It creates data information such as available network bandwidth and congestion and so on. What exactly is network status information that has not clearly defined in this draft? It will be updated in the subsequent draft. Okay, the next step will be continuously update and improve the draft. We will welcome any comments and suggestions. That's all. Thank you.
Thank you very much for the presentation. I see we have Chris already in line.
Yes. Hello. Thank you for the presentation. I'd like to ask, are you aware of the SCOAN working group? Because I'm trying to figure out how this relates to SCOAN, because SCOAN is conveying throughput advice to the sender. And it seems to be saying it's kind of like the same thing. It has the ability to convey throughput advice in the ACK that goes to the sender of the data. How do you see this?
Thank you. Personally, I prefer path awareness or endpoint network solution. So I think it's more suitable for this group.
Okay. I mean, I know Brian's got.
So I put myself in queue as the co-chair of the SCOAN working group. First of all, an ad, please come to SCOAN on Friday morning and do have a look at what we're doing over there. The information that we're putting into the packet in SCOAN is much more restricted, right? Like, so we have a very, very specific charter to fix a specific problem with as little information as we can get away with for fixing that problem, right? Whereas this looks more like a general purpose telemetry thing. I would say, though, all chair hats off now. I think the really interesting part of this work is the part that we're not talking about in this draft at all, right? Like, so adding the acknowledgement frame to Quick so that you can actually have a back channel here is something that, honestly, I don't think we should be talking about in PANRG. This is something that we should be talking about in the Quick working group, right? Because like extensions to Quick need to be done by Quick. The really interesting questions in this space would be like, how do you actually, like, what are the semantics of what's in that ACK frame, right? Like, what do you actually want to send back? And I think that would be something that would be very appropriate to talk about here. And we'd also want to talk about like the deployment incentives for building something like that, because the cases where we tried to do something like this before have kind of blown up, right? Like, and one of the reasons to have that discussion here in PANRG is that so we can kind of sort of figure out what is the what is a viable product that we could build around this, sort of in a more experimental framework. So PANRG chair hat back on, very interested in seeing future work in this case, in this space, not about the mechanics of how the data gets back via Quick, because, you know, one, that's not our scope. That's the Quick working group would be part of that. It's the semantics of that signaling and how exactly that's supposed to be filled in by the routers that I think are much more interesting.
And can I, yeah, if I can add a bit more. So I think, yes, you're right. This is a general purpose mechanism. And I think it's worth linking this to the IAB document on path signals collaboration, which I believe said, I may be quoting it wrong, but it's something about advising against general purpose signals like this and recommending specific single purpose signals that are then extensively analyzed for their impacts.
Right, which is where I think that, like, that's where, like, SCONE is like, here's a thing that we think is engineering ready that's a very, very specific one. If there are other specific problems that the authors of this draft are trying to solve, it would be more interesting to start with the semantics of those as opposed to the syntax of how you do the feedback, right?
Yeah, agreed.
Because the way I see that part of what we do in PANRG is have those discussions here for things that are not yet engineering ready, and bang on them a while, and then, like, you know, feed them through our open questions and then say, okay, this might be something that you could look at. Like there's possible engineering to do here.
Cool. Thank you.
Thank you, Chris, for the question. And I will remove myself from the queue. Tony. Oh, Tony, you're actually coming up to do the... Do you have a question on this thing, or are you ready to go on to the next?
And ready to go on to next.
Oh, okay,
next.
cool. All right. Well, let's do that then. Hold on. I will remove you. Oh, you have a slide request. Excellent. Hold on. I need to stop sharing, and then I can grant, and then you might need to click again. This was the same problem that Nicola had, I think. Perfect. All right, take it away. Thanks.
Thanks, Brian. So good afternoon, everyone. I'm Tony John from the NetSys lab at the University of Magdeburg. And now I'd like to present our work on DMTP, a deadline-aware multipath transfer protocol that addresses the needs for real-time applications. Modern real-time applications such as teleoperation, telesurgery, or even online gaming have three critical requirements from the network. Those are strict latency guarantees, high reliability, and predictable performance. Currently, in cases where these requirements are really strict, we use dedicated networks or leased lines. These are very effective, but comes with significant drawbacks, namely high costs, limited flexibility, and highly complex management overhead. This is where SIAM comes in. As a next generation internet architecture, SIAM offers path-aware networking and multipath support. This opens up new possibilities for optimizing real-time applications at the network level through our proposed protocol, DMTP. The primary goal of DMTP is to meet the strict latency requirements while ensuring reliable data delivery utilizing science path awareness. We achieve this through three core components. These are optimal path selection, smart retransmission, and adaptive forward error correction. Additionally, we also support multiple concurrent streams with different priorities, making it suitable for complex applications with varying requirements from the network. The first core component of DMTP is the optimal path selection, where we take multiple path metrics such as RTTs, the available bandwidth, loss rate, and path costs, and we feed into the optimizer, and the optimizer's goal is to meet the application deadlines and bandwidth requirements while minimizing the overall transmission cost. We employ a hybrid approach combining fast heuristics-based filtering and advanced optimization algorithms. The heuristics-based filters quickly filter paths that can't meet deadlines and allocates traffic proportionally over the selected paths based on weighted metrics. Running in parallel to this approach is an advanced optimizer. We have tried using linear programming and multi-objective optimization, and these solvers find truly optimal set of paths to use. The solutions from these advanced algorithms then feed into the heuristics filters and tune their weights, allowing our system to make quick decisions while converging to optimal behavior. The second core component is smart retransmission. Here in practice, we use a faster path among the selected paths for acknowledgements and retransmissions, and we make retransmission decisions by calculating if we can still meet deadlines and also check if we have enough acknowledged packets for reconstruction through error correction. And we also consider the congestion state of the path. This approach avoids wasting bandwidths on packets that would arrive too late and maintains predictable latency bounds for the streams. The third core component is adaptive forward error correction. We use Reed-Solomon coding. It supports multiple erasure recovery, and we adapt our coding rate based on observed loss patterns over the paths. The redundancy packets are sent via a different path than the main data path if we have multiple paths to decorrelate losses. This approach reduces the dependency on retransmissions while maintaining deadline adherence when we have random losses over paths. The MTP also supports multiple priorities for streams. Currently, we have 3 priorities. Priority 0 is maximum reliability. This is aimed at streams with that are really critical but low bandwidth. Here we can duplicate the data across multiple paths and make sure that we have maximum reliability there. And for priority 1 is aimed at streams that need high reliability and deadline adherence but are of high bandwidth requirement. For example, a critical video stream. Here we target high deadline achievement, and it uses the combination of forward error correction and retransmissions. The third priority is best effort. These are suitable for auxiliary streams. Here, packets will be dropped if the bandwidth is limited and free up bandwidth for the critical streams. We did experiments with the NTP over 2 paths, one high loss, high bandwidth path and one low loss, low bandwidth path. We in the experiment we increased the loss rate at varying steps. The deadline was set to 160 milliseconds, and the blue line represents how the coding rate was adapted with the increasing loss rates. The green spikes show that retransmissions happened when coding rate was being adapted. And overall, we achieved more than 99% of packets were sent within the deadline, even at a loss rate of 10%. We also compared the NTP with multipath TCP and multipath QUIC. Here we experimented with 3 variants of the NTP, one only with forward error correction, one with only with retransmission, and one where these approaches were combined. Looking at the performance curve, we see 3 distinct regions. At low loss rates, all of these protocols perform similarly well. At the loss rate between 0.5 and 2%, MPTCP begins to degrade. About 2%, both MPTCP and MP-Quick struggles, while DMTP maintains consistent performance even when the loss rate was 10%. The difference stems from fundamental design choices. MPTCP and MP-Quick optimize for high throughput and high number of connections, while DMTP prioritizes meeting deadlines and maintaining reliability. DMTP does use more resources per packet to achieve this, but this trade-off is justified when the applications require strict latency. We also validated DMTP in a real-world setting by collaborating with ETH Zurich's Robotic Systems Lab. We successfully operated an excavator remotely over DMTP. And for this test, we used Scion's testbed network called ScionLab. There is a video showing the difference, but since this won't transfer well in an online presentation, you can check the video from this link. So the result was that DMTP provided consistent performance for the video with considerably less jitter, and the operator had a good feel of how the excavator was moving compared to using RTP over the regular internet. So we are actively working on standardization through our experimental internet draft, the Quick Multipath DMTP. We propose minimal extensions to Quick and Quick Multipath to add support for deadline-aware streams. The key components of our proposal is a transport parameter for negotiating support for deadline-aware streams, a control frame to signal per stream deadlines, partial reliability mechanisms to retransmit within achievable deadlines, an optional adaptive FEC algorithm to reduce retransmission overheads, and mapping of paths available from path-aware networks to different path identifiers in Quick Multipath. We had feedback from the Quick working group. Their feedback was that they think this is useful even for single path scenarios. Another feedback was to use one of the drafts that proposes using one-way delay measurements. So we will be aligning with their feedback, and we'll be revising our draft accordingly. The next steps include revising the draft, making our extension composable with both Quick and Quick Multipath, and then creating a prototype implementation of this in Quick and collecting more performance data. That was it from my side. I'm happy to take any questions or feedback.
All right, we have a queue. Go ahead, Dave.
I have one very simple question and one that might be a little more complicated. The simple question is, the experiments that you did, how many parallel paths were you using? I didn't see it on the slides. Maybe I missed it.
It wasn't on the slide, so we used 2 paths, one high bandwidth and one low bandwidth.
So have you experimented with the behavior as you change the number of paths?
Yes, we have tried multiple paths, and when we have a higher number of paths, the deadline adherence improves.
Great. And then the slightly more complicated question is, how does this interact from a congestion control standpoint with other transports, or even when multiple of these are competing with each other over the same paths?
Yeah, we haven't did an extensive evaluation on that. So we haven't really looked at fairness from that standpoint. But if there is congestion on a path, we lower our syncing rate.
Rajiv?
Hi, can you hear me?
Yes.
Yes, we can hear
Okay.
you.
So Tony, I find this work quite interesting, especially from the standpoint of how it could potentially be used as part of the contribution leg in large-scale live streaming video workflows. One of the big things that we always look for on the contribution leg from maybe stadiums and other kind of live venues is high reliability delivery of the video stream into a point from where the rest of the distribution infrastructure kicks in. And over here, while deadline adherence is a really nice thing to have, I wonder about what measurements you have done in terms of delivery reliability. In cases when you encounter things like a link failure, okay, where it's not just loss but actual failure of a link, and how long does your protocol take to identify that and adapt around it, and what is the reliability characteristics of delivery during that period when it is failing away from a downed link. So do you have any stats around that, or have you done any experiments on that?
Yeah. So based on the availability of paths, we always try to keep one backup path in terms of a path failure. So if a path fails, path failure can be detected from losses. So we can immediately fail over to the backup path. And in cases where there is no backup path, we can so for the best effort streams, we can drop those packets and focus on the high priority streams. Yeah.
Okay. So the next question really is, where can we get access to any of your POC work? If we also want to, maybe run a test bed or something, how do we go about that?
We haven't open sourced the POC yet, but you can get in touch with me via email. I can provide you access.
Okay, great. Thank you.
Thank you.
So I threw myself in the queue to ask a couple of questions as an individual, but first I'll say, please actually, when you do have proof of concept code that's ready for experimentation and interoperability, please do send that to the PANRG at IETF.org list as well. I think there are a lot of people here who would be interested in looking at that. I had one clarifying question that I think is answered in the slides, but like I want to make sure I understand properly. You're using the ScionLab network basically because it gives you the ability to do path selection other than by just your local interface, right? Like, so the path awareness of Scion is nice to have, but not absolutely necessary for the implementation you have, correct?
Right. Yeah.
Okay, cool. All of the other questions I had, I think, are actually answered by your slide 20 about like working together with the multipath quick people on sort of pulling this in as a different point of the MP quick thing. I was actually sort of like, during your talk, I was chatting to MP quick people and being like, hey, you need to come look at this and you need to like be aware of this. It sounds like there is already a collaboration between MP quick and DMTP, because I think there is. This looks like it has a future is something deployable essentially as different points in the configuration space for MP Quick, right? Like, so this is like super useful, and very excited about seeing that sort of like deploy through there. Please do bring additional results. I think actually the looking into the details of the question that Dave raised with respect to fairness, a lot of the MP Quick people are also congestion control people. That might also be something that could be brought to CCRG. So the future experimentation there about how path selection interoperates with congestion control mechanisms. But please do keep us here in PANRG, both at meetings and on the list, updated with the continued progress here. And Rajiv is back. Hi, Rajiv.
Yes. So I have one follow-up question. This is more of a thought in terms of future direction. Have you guys considered scenarios where the multiple paths that are used might have a mix of technologies involved? Like, for example, having a primary path on a multicast network with backup paths on unicast, which are running probably at a lower rate, only carrying FEC data, and using that to massively improve the reliability of the main multicast path.
Yeah, we haven't looked at using multicast paths yet. But
Okay,
interesting point.
So yeah, that might be some potential for future collaboration. Let's see. Okay, thanks.
Thanks for the questions and discussion, and thanks, Tony, for the presentation. Again, please do keep us up to date with what's going on in this space. Super cool stuff.
Thank you.
With that, I think we are 15 minutes early. This is the last session of the day, right? Like, so I can let y'all go get some dinner. Oh wait, no, we have Rod. Rod.
Hi, Brian. Sorry, we're missing you here in lovely Bangkok. Yeah.
I am also missing me there in lovely Bangkok. But
so this is entirely apropos of nothing that has been discussed so far. But most of the people in the room know, but maybe not everybody does. I'm co-chair of the Quantum Internet Research Group. And at some indefinite point in the future, I think it would actually be fun to have a conversation with the people here in PANRG, and maybe also some of the people from DetNet, and figure out what quantum networking can learn from what you guys have learned. We had the QIRG meeting this morning, and I mentioned then there is sentiment for actually having a QIRG meeting in Madrid. But personally for me, just because of home academic calendar, that's kind of a difficult time to travel. So it's not clear that I'll be there in person, but let's touch base and see if we can learn from you guys at some point in the not too far but still indefinite future.
Yes, absolutely. Can you pull all three of those mailing lists into one mega thread, and we can figure out what that would look like? Or is that something that you want to do chairs first, or?
Let's do chairs first.
Okay, cool. Please drop us a line.
Dave Allran says we should just entangle the chairs or the working groups.
All right, thanks much. Any other business? Going. Again, apologies to all of you who are not in the room and watching this recording later for the conflict with Happy. For those of you in the room, thank you very much for joining us. We will, it turns out I actually have already booked Madrid, so I will be able to be there, which is looking forward to that. We will be having a PANRG meeting in Madrid as well, so we will see you all there. Thanks much, and enjoy the rest of your week. And special thanks to Dirk for sitting up front of the room, taking notes, and being up there for all eventualities. And thanks also to Nico for.
No problem. Yeah, thanks to Nicola for taking great notes.
Yep.
Cheers.
Bye all.
Bye, everyone. Take care.
That joke's gonna get really old. What? That joke's gonna get really old.
Not for a while yet.
Sort of like the favorite cats and like three-year jokes. You know, like,
I would tell you that the answer already went by, or that
well, there's, that guy who thought he was down. Like 3 years, right?
turned out to be loose connector.
Yeah.
So it goes, right?
So it goes.
Yeah. Loose connector, Nobel Prize. It was going to be one or the other. Right? Hey, how are you?
I just wanted to say hi.
Hi, I'm Rod.
I'm 56, so
Okay, nice to meet you.
past life, I had an interest in quantum networking,
Uh-huh.
and I read your book.
Excellent.
Ordered it like 3 times.
Excellent.
Wonderful.
Yeah, trying to work.
Were you in the QIRG meeting this morning? We had a quantum internet research group meeting this morning. Oh, that's too bad you missed it. Well, eventually they'll post the videos on YouTube. You can go take a look at it. Uh-huh. I understand that. From
I'm sorry, guys. If Rodney can still hear me in the room.
Pardon, say that again?
Hi, Rodney. This is Rajiv here, remote. I just wanted to. I overheard the conversation you were just having, and I just realized that even I've missed out on that session. So I look forward to looking at that recording once it's available. But I was wondering if having such a system for multipath delivery with an underlying quantum infrastructure could actually realize our dreams of FTL messaging.
The dreams of faster than light messaging. Sadly, no. Sadly, we're not going to give that to you. But we'll do new and interesting things for you. But if you're not on the QIRG mailing list, come join it. It's pretty low traffic and occasionally interesting.
Will do. Take care.
You too. Are you coming to the dinner tomorrow? Yeah, tomorrow.
Yeah, no problem. I also really like this multiple feature. It can be very interesting. Okay. Yeah.